Hello everyone, our topic is security in mobile application. In mobile application, the communication of client and server should firstly be ensured by authentication. The definition of application authentication is the process of verifying the identity of the user. The process of it can be summarized as follows. The user sends username and password to the backend. This username and password now can be instanced by biometric properties, one-time password generator, but the ideas of them are the same, using the sensitive information to determine who the user actually is. Then the backend checks the credential against the database to find that who the user is and whether the password is corresponding to a record for an existing user. When the user and the password are validated, the server is going to create a temporary string and send it back to the user. Once the user receives the string from the server, for each sequential request, the user is going to append the string at the end of the message. Then by checking the string, the server is able to know whose behalf of the requesting process and whether requirement is validated. And the string is tricky that user can log in one time and send many times of requirements. The string contains the state of the client and also called communicating credentials. There are two main types of strings. One is called session ID, which is stored in cookies, and the other is token. And today, by introducing the scheme of these two kinds of credentials as well as their main advantages and drawbacks, one improvement of token is also going to be presented. The first login credential is session ID, and it represents to the HTTP authentication. Now let's talk about the feature of session authentication. Firstly, the main feature of it is that the session ID for each sessions are stored in cookie on both client side and the server side. Second, because the user's session is stored in the server side, so it also called stateful authentication, which means that the session is persisted in the server side storage, for example in cache or database. Then the session ID doesn't carry any meaningful data, only random numbers are in it. Next, it is signed by a hashmark function to prevent the client to modify the content of the cookie. In addition, it's rarely encrypted, and if it is encrypted, it is often done by AES algorithm. Last, when the user decides to log out, the server is going to destroy the session and clear the cookie on the client side. Some drawbacks of the session authentication mechanism. First of all, it's hard to provide a service across different server instances, as the server needs to store the session information for every logged user. Besides, when a large amount of users logging at the same time, the server needs to consume a large amount of memory to store the session information of different users. This would limit the concurrency. Thirdly, the session mechanism highly depends on cookie of the web browser. Therefore, it can only be used on mobile applications which apply the web browser to provide the service. Finally, when dealing with session-based authentication using cookie, we are exposing ourselves to CSRF attack. But what is CSRF attack? Firstly, the user logs into site A, and the server returns the session ID to the user's cookie of the web browser. Then if the user starts to visit site B, which is a phishing website using the same web browser without logging out from site A, the phishing site would demand to visit site A using the session ID stored inside the cookies of the web browser, finally executing some malicious code on site A. As for token-based authentication, token is used instead of session ID. Let's talk about the generation of process of token now. Firstly, the session will encrypt the user information, such as user ID, using a secret key which is only known by the server, to generate a signature. Usually, the encryption algorithm is hashmark SHA-256. Then such user information and the signature are put together to form a token. Such a token would be sent to the user and stored to the local storage of user. Then, when the user wants to communicate with the server, it would attach the token with its request. The server would use the user information to generate the token again, and compare it with the one receiving from the client in order to do authentication. If they are the same, the authentication succeeded and it offers a demanded service to the client. Otherwise, the server would give an error message and ask for a new login action. There are some advantages for such token-based authentication. The most important one is that the server doesn't need to store the token. Therefore, it can save storage load for the server. Meanwhile, it's easy to achieve service across different server instances, as all server instance has a key to generate the signature. It doesn't depend on cookies of the web browser, so that it can be easily used on most mobile applications, rather than on only web browser-based application. However, once the attackers intercept the token in the process of the communication, attackers can illegally access or even modify the data of the server, which would cause serious problem. And for the security risks mentioned above, there is a new login authentication mechanism using RSA encryption token and user ID. The improvement of token-based authentication is mainly in the login authentication stage. The improved login authentication stage is as follows. The client sends a request to the server without sending its username and password. The server produces public key and private key using RSA and sends public key to client. Client generates hash value of user ID as sign, and then encrypt this sign, user ID, and this client public key using server's public key. The server can decrypt this ciphertext. Server produces a new sign using the same hash function and compares these two signs. If these two signs are identical, server would produce a token for target client and encrypt it using client's public key. And there is another improvement based on last scheme which can make the communication more reliable. Server can set an expire date for token. Additionally, set a refresh token with expire date. If the token is expired, client can apply a new token via refresh token. If refresh token is expired, client need to log in again.